Now we will see that event and so many topics we are going to covering today and this video. Types of event, impossible and sure event, simple event, compound event, and algebra of events. In that complementary event, the event A or B, the event A and B, and the event uh, A but not B, mutually exclusive event and exhaustive event. These many topics we are going to cover today. So in this video, first of all, we'll see that event, what is event. And before going to event, I have considered the two coin tossed once. So sample space, whatever we are getting is here, that is HH, HT, TH and TT. So if I consider the event and if I am tossing two coins once, then there will be, if I say that there should be uh, at least or fixed one head should be there, then my event will become HT. Is one possibility is there, that HT one head is there, and TH, this is another event which can be possible. So these two are favorable, so I'll call it as event. So each and every sample point is known as event only. Sample point I have explained in the last video or in the uh, previous slide we have discussed that. So these are the events. So occurrence of event means if I say that there should be uh, one head should be mandatory, that should come when you toss it. So it is HT and TH. The remaining things, these one HH and TT will not be there. So therefore that is not the favorable event. So occurrence of event will be this one only, HT and TH. Then types of event. So in types of event, this is impossible event and sure event. We will discuss about impossible. The name indicates impossible means not possible, or if I say two coins are tossed once, and what I am seeking is I am seeking three tails. Three tails. I wanted three tails, so it is not possible. So therefore it is said as impossible event and sure event. If I toss a coin, then definitely I'll get H and T. One coin if I am tossing, then I'll get H and T as a sample space. And whenever I am tossing, I am saying that it should be either head or tail. What I am looking for is head or tail. So definitely this is my favorable. Both the events are included to here in the sample space. So therefore it is said as sure event. A sure shot you are getting the uh, sure shot you are getting these things. I'll take another example. The die. If I roll a die, then sample space would become 1, 2, 3, 4, 5, 6. And if I say that roll a die and get a number less than, get a natural number less than 6, event E is said X such that X is natural number, natural number less than 7. So definitely by looking at this event, you can say that less than 7 each and every number is there, so it is sure event. Definitely you will get either 1, 2, 3, 4, 5 or 6 as your event, and you are getting the same thing. Now simple event, sure event, you will definitely get one of your favorable in that. Surely you are getting the things. So simple event. So we will come to the simple event. These are our sample space. So simple event is nothing but the event only have one sample point. That is, say in this case two coins are tossed once. That means in this case we will be having HH, E2, HT, and E3. This is TH, and E4, that is TT. These many things are known as simple events, as you will be having only one sample point of the sample space. And compound event, as we can say, if you required, I'll take another example, that event E11. I'll consider this one as 1 1. Okay, no problem. E11, you are getting that. Let us consider that you required tail. So one tail is required. At least one tail means what? You will be having HT, TH, and at least means it. At least one should be there, or more than one also it will be possible. So in event this 1 1, you are getting HT and TH and TT. These many sample points are there, or sample point more than one if you have in this your event, then definitely it is known as compound event. Now coming to the algebra of events. Algebra of events means you are adding, subtracting, or whatever the operations we are doing on this algebra of events, we will see that. So complementary event. So first of all we will see that complementary event. Then what is complementary event? So if any event is occurring, and let us say only head you required, only one head should be there, that is HT and TH. There are two sample point in this event E, and the remaining things are not there. This is only one head is required. That's why you are taking these two as your sample sample point as your event. So what you're doing is basically complementary event. So remaining things will be complementary to E, and it is represented by E dash, and remaining things will be HH and TT. This is the complementary to each other. That means if I found E intersection E dash, definitely I'll be getting a null set of 5 over there. So this is complementary event. And E union E dash will get sample space S. These two results one should remember. Now the event A or B. In the set chapter we have studied the meaning of OR is nothing but union. That is symbolically we have represented that union, this one, and meaning common or intersection, that is intersection. Meaning is this one. So the event A or B means we have to find out the union between these two, event A or B, either that is in event A or B or in both, then only we will consider that. And in event A and B, if this particular event is or sample point is common in these two, then only we will consider. So we'll see that by the next example. Now let us consider A or B. If I roll a die, then sample space will become 1, 2, 3, 4, 5 and 6. The event A or B. So if I say there is a event E1 for such that it is odd number, odd number, and event 2 is nothing but prime number. Event E1 is to get, whenever we are rolling out this die, then we are getting odd number over there. So I'll again write E1 as 1, 3, 5, and if we roll, then what we are getting is prime number is 2, 3 and 5. So E1 or E2 will give you 1, 2, 3, 5 and no 1, 2, 3, 5. This is our event A or B, or event E1 or E2. I have taken E1, E2 over here. One can write it as AB. It will be much better. A or B. So we are getting A or B over there. Okay. So if we are talking about the event A and B, that means this is A or B, this is A and B. If the particular thing is present in both A and B, then only we will consider that as our, that is nothing but the 3 we are getting over here and 5 also we are getting over here. So our answer will become 3 comma 5. So the event A and B will get the intersection of there. And if I consider that the event A but not B, I'll write over here. I'll write here event A but not B. That means I have to consider A but not B. So I'll subtract B from A. So this is A, this is B. So what I'll do is I'll subtract, or I'll write this is as of mathematically I'll write this is B dash. So what I'm getting is I'm getting the same thing 3 and 5, 3 and 5. This is the common in these two. So I'll eliminate 3 and 5 from A. So what I'm getting is 1. This is my answer for event A but not B. So A but not B is considered as A minus B. A or B, this one is considered as A union B, and this is A and B is considered as A intersection B. Now we will see this mutually exclusive event, and this is very important one. Basically questions will be of this type only, and we have to emphasize this very much. So what I am taking is I am taking an example of rolling a die or throw a die, and the sample space you are getting as 1, 2, 3, 4, 5, 6, and I have considered two events. Event 1 is nothing but if you are throwing a die, then you are getting odd numbers over there. Odd numbers if you get, then definitely 1, 3, 5 is your favorable, or this is in your favor. And if it is said as to get the even numbers, so we have 2, 4 and 6 as our even number. So mutually exclusive events means there are two events, and these two events are mutually uh, entirely different from each other. Or if I say E1 intersection E2, then I'll get 5. This is the one of the definition for mutually exclusive event. This is one of the conditions for the definition. And E1 intersection E2, if we get nothing, that means we can say these two events are mutually exclusive event. And also if I consider as E2 sorry E3 as prime number, so prime number is 2, 3 and 5. In that particular we have prime number. If we say that getting a prime number, the event of getting a prime number is 2, 3 and 5. If I consider E1 and E3, what I have is 3 and 5, and it is not equal to 5. Therefore E1 and E2 E1 and E3, these two are known as not mutually exclusive event. Not, this is not mutually exclusive event, as we are getting other than 5 over there. Exhaustive events. Let us consider there are so many events as E1, E2, E3, likewise, and what we are doing is we are finding union to that En. N events are there, E1, 2, 3, 4, 5 up to En. Then we can write these as union from I equal to union of Ei from I equal to 1 to N. We can write it that we are getting union from I equal to 1 to N. So now it will become sample space. It will become sample space. Then we say that these so many events are exhaustive events. These events are known as exhaustive events. These events. So exhaustive events means if I consider E1 and E2, 2 itself is known as exhaustive event also. And if I consider 1, 2 and 3 also, then these 3 are also exhaustive events. And whenever I am doing any random experiment, I am getting the events, or I'm getting the numbers over there in my favor. So it is that much of theory is needed to solve exercise 16.2, and we'll see one or two questions to solve. Now the question is, two dice are thrown and the sum of the numbers which come up on the dice is noted. Let us consider the following events associated with this experiment. And the 4 experiments we have done, and first one is the sum is even, and second is the sum is multiple of 3, fourth is third one is the sum is less than 4, and the fourth one, that is D, the sum is greater than 11. So in this 4 experiment we have done, and which pair of these events are mutually exclusive? This is the question, and we'll go through the solutions also. Solution says that first of all, there are 2 dice thrown. Therefore what we will do is we'll first of all find out the sample space of that experiment. So the sample space, in there we have 36 elements in the sample space, and it can be given as this is the sample space. I have written over here in the set builder form to express the set builder form of this sample space. This is nothing but sample space S, that is xy, such that xy is equal to 1 2 3 4 5 6. So it will become 1 1 1 2 1 3 1 4 1 5 1 6. Likewise you have to make yourself. And after that we will consider the first one, that is A. A is saying the sum is even. So we have considered all the events which are giving the sum, that is 1 plus 1 is equal to 2, 1 plus 3 is 4, 1 plus 5 is 6. Likewise 4 plus 6, here we can see it is 10. This is 5 plus 1 is 6. So likewise we are adding these two numbers and we are getting the sum as even. So these many things are our events. These are the sample points we have taken in this event. So in B, the sum is multiple of 3. We have considered so many sample points as our event, as these two will give the multiple of 3. That 1 plus 2 is 3, 1 plus 5 is 6, 2 plus 1 equal to 3, and likewise everywhere you can see here this is 2 4 3 3. If we add all these 4 plus 2, like, so we will get 6, 4 plus 5 we will get 9, 5 plus 1 we will get 6. So each and every number or ordered pair here you can see these are the multiple of 3. Now point number 3, that is C, the sum is less than 4. So I have considered 1 1, 1 2, 2 1. These are the sample points which will give us the sum as less than 4. As you can see, there is nothing you won't get other than these as less than 4. So this is fourth one, that is D, the sum is greater than 11. So sum is greater than 11, so there is only one sample point is available, that is 6 plus 6, that is 12. So we are getting only one sample point over there. So this is also known as simple event, or that is elementary event also. So we find that A intersection B, first of all for mutually exclusive event, here it is asking that mutually exclusive event, we have to find out the mutually exclusive. I have shown over here that for mutually exclusive event we have to find out the intersection, and that should be equal to 5, or null set you should get. So what we are doing is one by one we will find out A intersection B. We have found so many events are there which are present in A and B at the same time. So it is not equal to 5. Therefore, these two events A and B are not mutually exclusive events. Similarly, if I go for A intersection C, A intersection C, 1 1 is there, 1 1 is also here. One element is, or one ordered pair is sufficient to eliminate from mutually exclusive event. So we are getting 1 1 as common. I need not check for others. So directly I can write this is not equal to 5. A and D. If I consider A and D, so D is 6 6 and I am getting 6 6 over here. This one and this one. These two are there. That's why these are not equal to 5. And B intersection C. This is B intersection C. Here I am getting 1 2 and 2 1 as my event, and here I am getting 1 2 and 2 1 as here also. These sample points reflect that B intersection C is not equal to 5, and I'll check this B intersection D. Then here I will be having this 6 6 as my one of the event, one of the sample point, and this is also one of the sample point we have. So these two are common. So therefore we are also not getting B intersection D as empty, or we are getting this is 6 6. So these many events we have checked whether they are mutually exclusive or not, but the pair AC, AD, BC and BD, these are not mutually exclusive events, and we have already mentioned about AB, that's why we have left that, and remaining portion we have mentioned. that these many events are not mutually exclusive. Now I have checked, I have made a pair with A with B, C, D, B with C and D, and now I am going to make pair with C and D. So if I consider these two events, then there is no such elements I am getting over there that is common. So what I am getting is, sorry, this is C intersection D. This is C intersection D. I am getting 5. Therefore, I can write C and D are mutually exclusive events. So, likewise, you have to find each and everything, each and every question you have to solve likewise. So, I am stopping here and I'll move further.